All right. So, continuing on through chapter 9, we're over halfway here. But 9.5, we're going to start off here with the kickoff. So, draw all the lines of symmetry of a regular hexagon. So, hexagon, six-sided shape. So, anyone going through these flat sides, you would have those, plus any of them cutting through corner to corner. So there should end up being 1, 2, 3, 4, 5, 6 different lines of symmetry when you do it. Okay. So moving on into 9.5, everything we've done has involved isometries. So an isometry, and I guess before I go on, keep in mind when you're watching these videos, you know, if there's a point where I get going too fast, doing too much, you can always pause it if you need to write stuff down, or you can rewind it. Let me hear, so you can hear it again. Let me, say it again for you. So don't forget about that. But like I was saying, everything that we've done up to this point has been isometries. The size, the shape, none of that changed. We just changed the position of our figure. Well, that's all going to change. We're going to start here with dilations. Dilation is where we're either going to make it smaller or we're going to make it bigger based off of a scale factor. So like if a scale factor is 2, everything is going to be twice as big. Scale factor of a half, everything's going to be half the size, which is what we're getting into here. So anything bigger than 1 is going to create an enlargement. It's going to make it bigger than what it was. Anything between 0 and 1 is going to be a reduction. It's going to make it smaller in size. Now, we can't have a scale factor be less than 0. So we can't have anything negative. And if you think about it, I mean, size-wise, nothing can be smaller than 0, than nothing, okay? So, like here, so our red is our original. The blue is the image. Then what we're going to, this would be an enlargement, scale factor 2. Everything's twice the size. So if this side was 2, our enlargement, we would have a size of 4. Here we would have a reduction. So again, we're going from red to blue. We're going from the bigger down to the smaller. So this would be a scale factor of 4. Everything's 1/4 the size. Now, notice here, our center on our first one was at A. So everything is building off of this. So A doesn't move if it's a center. You're stretching away from the center, whatever size you need. Here, C was our center, so everything came in. Okay. So the center is where that dilation happens, whether it's enlargement, reduction, but it's all going to go off of that. The center does not change no matter what. So if we have our figure and we're finding that scale factor, you want to pick a side. So looking at this, so X and X prime, they're the same. So our center is here at X. That's where all of our changing is going on. Our dilation is happening. So if we pick a side here, we have XT as our one side. So that's the original. The original is going to go on the bottom. Our new, though, is going to go on top. So that's going to be X prime T prime. Okay. So, well, what are those measurements? Well, X to T here is 4. Now, from T to T prime is 8. So we're going to add that in from X to T to get the full size. So 8 is just this little bit. X is this little bit. We're going to put them together to get the whole side. So 4 and 8 would make 12. So if we divide that, 12 divided by 4 would be 3. 3 then would be our scale factor. So everything would be times by 3. So whatever the coordinates are here wouldn't change because it's a center. But the coordinates of T, we'd take it times 3 to get it to be the new spot. R, we would take it times 3 to get it to its new spot. Now, we can also do this without figures, but I guess the figure in imaginary sense, I guess in this case. So packaging lists a model's car's length as 7.6 centimeters. It also gives a scale of 1 to 63. So any toys that you got, wow, that's terrible English. I am sorry for whoever's listening for my English here. Any of the toys you have received in the past, purchased or given to you, none of them can be the actual size of that car, that equipment, whatever. So like if you got a toy car, a toy tractor, it's always scaled down. Like, one of my more common toys that we always had growing up was the 1/64th size tractor. Well, that's a scale of 1/64th of the size. So if we shrunk that by 64, all the measurements, we'd have that size of tractor. Same thing with the cars. They're always a scaled down version, and if you flip them over, it's got the scale on the bottom in case you're curious. But in this case, this car was scaled 1/63. So we're going to set up a proportion. So our toy over actual. Okay. So in this case, it says the model car's length was 7.6. So we're going to put 7.6 cm on the top. So if we want to find the actual length, we're going to do it on the bottom. So we're just setting up a proportion. We'd solve it just like any proportion in the past by cross multiplying. So we're going to do 63 times 7.6. And then divide by the 1. Well, dividing by 1 is the same thing no matter what. So x would equal 478.8 centimeters. Now, that's a lot of centimeters, so it would also be 4.788 meters if you want to go that route. Either way, same thing. All right. So when it comes to shapes, like I have the little note here, you never multiply the center, but every other coordinate's just going to get multiplied by 3. So if our center's at 0, 0, none of these are on that center, so they're all going to get multiplied. So P prime, so after we multiply it, if it's 2, 0, 2 times 3 would be 6, 0 times 0 still say 0. So our new point would be at 6, 0. Now this is small enough, it's not on that right scale, but 6, 0 would be 1, 2, 3, 4, 5, 6. It'd be like clear out here. You can't even see it. There we go. So our next one would be Z prime. Again, you're just multiplying by 3. So if it's -1, that would become -3, and 0.5 would become 1.5. So -3, 1, 2, 3, 1.5. We'd be up here. Okay. And then G prime, we're at 1, -2, so taking it times 3 would be 3, -6. So 1, 2, 3, 1, 2, 3, 4, 5, 6, somewhere down here. So then we'd have this shape, which is now 3 times larger. Now again, it kind of looks like it's offset, like, hey, why isn't there as much of a growth here when we've got more growth here? Well, again, our center's at 0, so we're building out from that center. So again, that point doesn't change, but everything else does. So we're growing from that point. Okay. And that's it for this lesson. So if you have any questions, comments, concerns, please let me know. Otherwise, until next time, we'll talk to you later.